Hello and welcome to this channel. If you don't know me by now, I'm not Mick Hucknall or Harold Melvin. My name is Dick van Oeveren, and in this 9th video I will introduce user-based tunneling with local user roles. In the first 5 videos I have covered the concepts around user-based tunneling and user roles. So if you want to refresh your brains, just check out these videos. You can find them in the playlist. As said, this video will cover the configuration of user-based tunneling with local user roles. This will include the configuration of a local user role with local breakout. And for this scenario I will be configuring MAC Authentication 802.1x and Captive Portal. Before I start with the configuration, I think it is important to explain how the Captive Portal functionality works with wired clients. It is slightly different than the Captive Portal process for port-based tunneling. Let me show you how this works. First, when a client connects to the switch will send an authentication request to the ClearPass server. The ClearPass server will authenticate the client automatically. For this, a MAC authentication service is configured on ClearPass that authenticates the MAC addresses by default. That service also pushes a radius attribute back to the switch containing the user role that contains the Captive Portal redirection parameters. And this user role is assigned to the client. Then when the web browser is opened, typically the client sends a DNS request and receives a response. Once the response is received by the client knows how to access that web server. However, when the client wants to connect to that server, the request is hijacked by the switch and the request is redirected to the Captive Portal server. And this Captive Portal server then returns the Captive Portal login page. The client performs the authentication, which is a web-based login. When that authentication is successful, ClearPass sends back a response containing the port bounce instructions. So basically a change of authorization message. This message bounces the port and forces a re-authentication of the client. Now, because the client has already been authenticated, the third authentication, which is a MAC-based authentication, will then automatically authenticate the client and assign the appropriate user role to that client. Now, when I get to the Captive Portal configuration section, I will explain the whole process whilst going through the configuration. Back to the configuration. Let me show you the configuration steps for the switch. The switch configuration will be comprised of the following. I will do the radius setup, that's including accounting. Set the tunnel node server mode for role based. It's now configured for port based. Create the user roles. Configure the VLANs and assign the VLANs to the uplink port as tagged members. And configure security on the access ports. Here's the diagram again with the setup, which is pretty much the same as in the whole video series so far. Remember that for local user roles I am not downloading any information from ClearPass other than a radius vendor specific attribute. So at this moment I don't really have to configure things like time synchronization and certificate downloads on the switch. So I will do that when it becomes relevant with the downloadable user roles. For the local user role without secondary user role, I don't have to configure anything on the mobility controllers because there will be no tunnel established on, to the mobility controller. But for authentication, authorization and accounting, I do have to configure ClearPass. On ClearPass, I will be configuring the appropriate profiles, policies and services for the local user roles. And I will also show you some additional stuff like role mappings, so that's going to be configured as well. So for the Captive Portal setup, I will explain how that process works when I get to the Captive Portal section of this video. So we'll set up the switch first. The first step is to configure the radius component, and let me do that. So this is the ClearPass server, providing the key, and I've got another parameter 11, which is the dynamic authorization parameter, and that's a feature that is used, for example, by Captive Portal. So that's the change of authorization. And the other thing I will configure for the Radius server is the time window. So this parameter is the time window in seconds within which the received dynamic authorization requests are considered to be current and accepted for processing. Now for user-based tunneling we don't need a time value for this, so we set this to 0, which basically means that any value is acceptable. And the other thing I'm going to do is I'm going to enable accounting for Radius. So I'm going to set the periodic update time to 10 seconds and accounting network enable the start stop for Radius. Okay. Next is to change the mode of the tunnel node server operation to role-based instead of port-based. So this means that port-based tunneling has to be disabled on the ports. That's what I'm going to do first. Node tunnel node for the 3 interfaces. Now before I enable the role-based mode on the switch, let me start debugging, because you will see quite some things changing when I change that mode to role-based. So I'm going to do debug destination session, debug event, and debug user tunnel node. Okay. And now I'm going to change the tunnel node server mode from port-based to role-based. And you see, so when I change the mode to role-based, the switch will move from port-based tunneling to user-based tunneling, which will introduce the concept of the control plane with switch anchor controllers and the data plane with the user anchor controllers. Now when I issue a show tunneled node server state, you can now see the user anchor controllers and the switch anchor controllers. Let me also show you the bucket list. So you can see the bucket list here with the 4 controllers in the cluster. So I assume this looks familiar if you have seen the earlier videos. And now for the user roles. I also want to be able to have the ports that we're running in port-based tunneling concurrent with user-based tunneling. Now because I'm covering quite a lot in this video, I will show you this configuration in one of the next videos. But as a heads up, once role-based mode is enabled for the tunnel node server, you actually don't run through port-based tunneling anymore, but all the tunnels become user-based tunnels. I have to configure the device mode to port-based in the user role and then make some other changes on ClearPass. So I will be leaving port 1 and 3 for now, and I will use port 4, 5 and 6 for the user role configuration. Okay, so back to user roles. Remember that a user role is a construct that consists of parameters that are associated with a specific client or client group. This can be a VLAN ID, a PoE profile, an ACL, traffic shaping policy, etc. etc. So therefore the process for creating local user roles consists of the configuration of a class, a policy and then creating the user role on which you assign the class and policy and optionally other parameters. Let me first create the classes that will be used for the MAC Authentication 802.1x and captive portal user roles, starting with a class that classifies all the traffic. Let me just do no debug all, just so that I don't get all these messages when configuring. Okay, let's start with the class. Class IPv4 all traffic. And in this class I will match all the IP packets. So that is any. Okay. Next is to create a class for MAC Authentication. And in this classifier I will basically want to classify the devices or the services that are allowed for the MAC authenticated client later on in the policy. So for this class I will allow for example ICMP and a TCP port which could be used for video streaming, for example. Okay, so class IPv4 camera, and matching the what's it, ICMP? Yeah, ICMP any. And I'm adding another rule that allows TCP port 9000. Any equals 9000. Okay. And next is to create a couple of classes for the captive portal. So the first class is for DHCP and DNS. So when a captive portal client connects to the network, it requires an IP address and DNS access. So I need this class definition created and later on assigned to the policy. So class IPv4, let's call it DHCP DNS, and I'm gonna match UDP any equals 67, and another rule for DNS 53. Okay, and the next class is very important for the captive portal. So as explained earlier in this video, this class is required for hijacking the HTTP request, and when this class is triggered, the request has to be redirected to the captive portal. So this is the class that is classifying HTTP and HTTPS traffic for any source and destination. The class IPv4, let's call it captive portal, and let's match any for oh wait, it's TCP traffic, of course, equals port 80, and I can add another rule, CP any equals 443. And then I have another class, and this class is for allowing access to the captive portal page. So I'm classifying the ClearPass server here. Class IPv4 ClearPass 10 match IP, and the source is any, and my destination would be my ClearPass server, which is a host. So that's going to be my mask. And then the last class is applied when the captive portal user is authenticated for the second time. So I would like to have the captive portal client have access to all services except for a specific subnet. You know, but at the end it's up to you what you want to, what the client to have access to. So let's create that class, IPv4 guest, 10 match IP any, and then the destination would be 192.168.0.0, and so on. That's the subnet. Okay, so later on I want to deny access to this subnet for the guest user. Next is to create the policies for the MAC Authentication 802.1x and Captive Portal user roles. In the policy I assign the service, but I can also do things like traffic shaping. Let me start with the MAC Authentication policy for the camera. In that policy I only want to allow DHCP, DNS, ICMP and the TCP port that I have configured in the camera class. Let me create that policy. Policy user camera. And so what I'm going to do is I'm going to assign those classes to this policy. So that's 10 class IPv4, what was it, a DHCP DNS action permit. And I'm going to add another class, which is the camera class. And I'm going to deny all the other traffic. Action deny. Okay, next is the 802.1x policy, and that's an easy one. In that policy I want to allow all traffic. So create another policy, policy user allow all, and I'm going to add a class there, IPv4 all traffic action permit. Okay. Now for the configuration on the switch for Captive Portal. For this I need to create two policies. One is for redirecting the client to the web portal page, and the other policy is for assigning the appropriate services once the client has authenticated. Okay, let me start with the easy one, which is the authenticated policy. In this policy I want to allow all traffic except traffic to the network that has been configured in the guest class, which is subnet 192.168.0.0/24. Of course, for this subnet I do want to enable or allow DHCP and DNS traffic, because the DHCP server and the DNS server are on that subnet. Okay, so policy user guest, and then 10 class IPv4 DHCP DNS action permit. So I'm permitting DHCP and DNS. And another class is for the for denying the subnet, and that's guest action deny. And the final class assignment is to allow all other traffic. Permit. Okay. And then next is the policy for the Captive Portal redirection. So before I create this policy, I will create a Captive Portal profile on the switch that contains the relevant configuration for the Captive Portal, and I will enable the Captive Portal redirection on the switch. I can then assign that profile to the user role later on. So let me configure that that Captive Portal profile first. So that's AAA authentication, Captive Portal profile. I'll just give it a name, Captive Portal, and then I have to specify a URL, HTTPS let's guest and then wired portal.php. Okay. Now for the wired captive portal, I'm using a different web page, which I will create later on in the video. The reason for creating a different web page is because the authentication process is different. With a mobility controller based captive portal, the login authentication request is based on the form submittal. So the controller performs the authentication request, and with the switches, when the web authentication is successful, ClearPass sends back a change of authorization. So it's a different method of processing the authentication request. Okay. And next is to enable the captive portal functionality. Authentication, what was it? Captive portal enable. Another thing I have to do is, because I have defined the DNS in the captive portal profile, I'm just also going to configure the DNS server configuration on the switch. So IP, DNS server address, setting a priority 1, and I'm setting this to the internal DNS server I have on the network. Okay. Now we can create the policy and assign the captive portal profile to that policy. So policy user captive. Let's give it a name: captive portal redirect. Okay. So for this policy, I need to allow, so I'm going to do 10 class IPv4 DHCP DNS. So I have to allow the DHCP DNS action permit, and I'm going to add another class. For this class, I am allowing access to ClearPass, and what I'm going to do is I'm going to add some rate limiting stuff here. So rate limits kbps. So my rate limit to ClearPass will be 1 meg per second, and I will assign a priority 4. So I will put a p-value to it. Okay. And then so the next parameter is important. So this is the hijacking line that instructs the switch to redirect the captive portal class to the captive portal. So that's another line: 30 class IPv4 captive portal action redirect to the captive portal. So now that all the profiles are created, we can now start creating user roles. And so I'm going to start with the MAC Authentication user role for the camera. That's AAA authorization. Sorry, I have to exit the policy, otherwise it doesn't recognize the command. Authorization user role name. Let's call it UBT. For user-based tunneling, local user role, camera. So this name is actually the name that I'm going to push later on with the vendor-specific attribute from ClearPass. So for this policy, or for this user role, I'm going to assign the policy camera, and I am going to put this camera in VLAN ID 110. Okay. Create another user role for .1x. User role name UBT local user role dot 1x. And for this user role, I'm going to allow all the traffic. I'm gonna use VLAN ID 120. And then for the captive portal, I need two user roles. One that performs the redirection and one that is applied to the authenticated guest user. For both roles, I will use the same VLAN ID. Of course, if you want to assign different VLANs for the pre-authenticated web guest, that's fine. First, the redirection user role. So in that role, I have to assign the captive portal redirect policy and then assign the captive portal profile and the VLAN ID. So AAA, authorization, user role, name, UBT, let's call it redirect. I'm going to apply the captive portal redirect policy, and I am also going to assign the captive portal profile captive portal to this user role and VLAN ID 100. So that's for the redirection. And then finally the user role for guest access. That's AAA authorization user role name UBT user role guest policy guest and VLAN ID 100 as well. That's it for the user roles. Now let me configure the VLANs and assign the uplink port as tagged member of those VLANs. One important thing to know is that with Captive Portal, the VLAN that is used for the Captive Portal functionality requires an IP address. So what I will do here is to configure the VLANs to receive an IP address from the DHCP server, so we should be good there. Another thing that I will be configuring is an IP helper address. The IP helper address is especially useful for the profiling functionality in ClearPass. So when a switch receives a DHCP request, it can snoop the request and forward this request to the ClearPass server. And this helps ClearPass in profiling the clients. Now let me get all of that done. So I'm going to enable DHCP relay first, and for the VLANs I'm going to set the IP address to DHCP boot P, and I'm adding a DHCP helper address, which is the ClearPass server, and I will be adding port 8 as tag uplink port. Okay, same for VLAN 110. Set the IP address, set the helper address, and set the tag port, and VLAN 120 as well. Okay. Another thing that I need to do is I need to enable the user role functionality. And that's the AAA authorization user role enable command. And then finally for the switches, I have to configure port security. The good thing about using user roles is that we can now start working with colorless ports. So this means that I can enable all the security methods on the access ports, and it really doesn't matter what I connect to those ports. It will always apply the right user role based on the identity of the device. So I will start with MAC Authentication and then configure port 4, 5 and 6 for role-based dynamic segmentation by setting an address limit and then enable MAC Authentication on those ports. So that's AAA, port access, MAC based, that's port 4, 5 and 6. So I'm going to set an address limit of, we'll say 3. So remember, I can have up to 32 clients connected to a single port for user-based tunneling. And then, okay, so that's the address limit, and this is the command to enable MAC-based authentication. The other thing I want to do is I want to set the MAC address format for MAC authentication to multi-colon. Let me show you the command. I have different options. Port access, MAC based, what was it, address format. So these are all the options. So really what I want to have is I want to have this address format, which is multi-colon. So I'm going to enter multi-colon. Okay. And then finally configure 802.1x access. For this I have to set the authentication method to EP radius because I'm using a radius server as authentication server, then enable 802.1x on the ports and enable 802.1x globally. In the configuration I also have to set a client limit for 802.1x, otherwise I cannot run MAC authentication and 802.1x at the same time on a port. Okay, so AAA authentication, that would be port access EP radius. And then I'm going to set a client limit. Sorry, that's port access. Authenticator, and then that's for port 4, 5 and 6. I'm going to set a client limit of say 3 as well. And then enable 802.1x on those ports, and then I'm gonna globally enable 802.1x. And so that's your configuration for the switches. Now before I move to ClearPass, let me check whether all the VLANs have received IP addresses. And yes, that's the case. So all the VLANs are up and running and they have the appropriate IP addresses. Now for ClearPass. So for ClearPass I will introduce the concept of roles and role mappings. Roles are a very powerful feature in ClearPass. So with roles and role mappings I can assign rules to a service. So when a service is triggered and that service is mapped to a role, then the rules in that role are executed. Let me explain this with an example that I will use for the captive portal functionality. So imagine that you are a hotel guest and access the network through a captive portal. The hotel will allow you access for 1 day without requirement to log in after a disconnect. So in other words, if you leave the hotel in the morning and reconnect your PC in the evening, you have immediate access, so you don't get this captive portal page in your face. If you return to that hotel a month later, you will have to log into the captive portal again, although your client information is already known by the system. So with a role mapping I can achieve this. And let me show you how this works. First I will be using an existing role. And that's the role you can find here, which is called MAC caching. I will use this role later on in the ClearPass policy. For that role I will create a role mapping. So let me create one. And let's just call it UBT captive portal expiry. and I'm setting the default role to other. Okay, and so in that role I will create a rule. So in this role mapping I will create a rule that verifies the time when the client logs in. So I will be checking against the time source database. So what I'm going to do is going to add this role, and the authorization would be the time source database. And then, so what I'm going to do here is I'm going to check whether the time of the login is smaller than the expiry time that has been set after the initial login. So for now, don't worry about the configuration, and I will show you that later on. So for now, it's important to understand what is done in the role mapping. So this rule will check whether my current logon time is within the expiry time. Okay, so that will be now is less than, and now what I have to enter here is I have to enter a parameter here, and which has to be correct. Endpoint, that's gonna be a colon, would be the MAC auth expiry. Okay, so this is a parameter that I'm using. So these are predefined parameters in ClearPass that I can use. Okay. So explaining all these parameters goes far beyond what I'm covering with dynamic segmentation. So that's I'm not going to cover that. So when this rule is triggered, I am going to apply the MAC caching role. Okay. Now that the role mapping has been configured, let's move to the profiles and policies and services. So, oh, of course, I have to save it. Profiles. Okay. So for the profiles, we need a couple of profiles here. I will start with a profile for the camera. Okay, let's do that one. It's a radius-based enforcement. Let's call it camera. And I will add an attribute here which comes from the Hewlett-Packard Enterprise Dictionary, and that attribute is called HPE user role. And so for the camera, so I've created a user role on the switch which is called UBT local user role camera. Okay, so this is the VSA that will be pushed by ClearPass back to the switch when the camera authenticates. Now let me do the same for 802.1x, radius-based enforcement .1x, and I'm going to add that same attribute here. User role, UBT, local user role, and that would be the .1x user role name that is configured on the switch. For the MAC Authentication section of the captive portal, I need to create two profiles. So one is for pushing the redirection user role, and the second one is for the authenticated user. Again, that's a radius-based enforcement. Let's call it redirect. And again, add that attribute. That's all pretty straightforward. It's the same for all the all these profiles. That was the redirect user role name. And a fourth one, which is again a radius-based enforcement, UBT, local user role. Let's call that one guests. User role equals, that would be UBT, local user role guest. I also need another profile that is used to set the expiry time for the client session. So a couple of minutes ago I showed you the role mapping where the login time is checked against the expiry time. Now when a client logs onto the network on the captive portal using the web authentication service, that service has to execute a profile that sets the expiry time. So now let me show you how this profile looks by creating one. What it is a ClearPass entity update enforcement profile. So I'm using that template. Let's give it a name, UBT captive portal expiry. And I need to add an attribute here, which is for the endpoint. So I'm using the endpoint database and I'm going to update an attribute for the endpoint in that endpoint database. Endpoint, that would be the MAC auth expiry, and I'm going to set a value here which is 1 day. So I'm going to explain that in a minute. So again, this is a very complex entry that I'm going to set here. Authorization, and I'm going to check the time source. That would be 1 day DT. Okay, so you can see it here. It's very important that the syntax is correct here. Let me save that one. So with this entry, I set the expiry time for the MAC authentication to 1 day. Now I understand that this entry might be a bit complex to comprehend. So let me show you, let me show you how that looks like. So you remember the 1 day DT value. So if I check my time source database here, if I go to attributes, you can see in the list here there are some aliases here. So what you can see here is the 1 day DT. So I'm actually using this alias in the profile. So again, I will leave all of this with ClearPass. I will not cover this any further because that's just, just too much to cover in in a 1-hour video. There's another profile that is used by the web authentication service. This profile already exists in the standard install of ClearPass. Let me show it. It's the bounce. Let me just filter on bounce. That's this profile. Now the bounce switch port profile sends the port bounce VSA to the access switch. So this is sent to the switch after successful web authentication. Okay, so the COA bounces the client access port and causes another MAC authentication to take place. And then because the MAC address is already cached by the previous MAC authentication, the client will automatically be authenticated with MAC authentication, and then the guest role VSA will be applied and pushed to the access switch. So you can see an attribute here call the HPE port bounce host with a value of 12. This value represents the number of seconds that a port stays down. So this means that after a successful web login, a client has to wait for at least 12 seconds before the port comes up, and then wait for another couple of seconds before there is access to the network. Now, because I have configured the same VLAN for the redirection to the login page and the actual guest network, there's no real need to have a long bounce time. So the client remains in the same subnet, so there is no need to obtain a new IP address. So this means that I can lower this value to, say, 2 seconds. Now, because this profile is a system profile, I cannot make any changes to the profile. So what I can do is I can copy this profile to a new profile, which I will do. So I will do that. I will copy it, and then I can edit that profile. Okay, so what I'm going to do is, let me just remove that, give that a name, UBT port bounce, and then I can change that attribute to, say, 2 seconds. Next are the policies. I will create 3 policies, one for MAC authentication, one for web authentication, and one for 802.1x. Let me start with the MAC authentication policy. Let's call it UBT MAC auth. Okay. And so both the MAC authentication and so the captive portal and camera authentication profiles can be configured with this policy. Okay, so let me go to the rules section and create the rules. So typically the rule configuration starts with very specific rules, and then the bottom rule is the most generic rule. So what I'm going to do is I'm going to add the camera rule first. So for the camera rule, I will check the endpoints database. And so normally you should find all the devices that are identified by ClearPass in there. And so what I want to check on is the so whether the device has been categorized as a network camera. So my category should equal network camera. Okay, and the other rule that I will be using is the user authenticated rule. So when these rules apply, I want to apply the local user role camera profile. Okay. The next rule is for the authenticated guest, and in this rule I will use the MAC caching role. Now this is the role that I have configured earlier, and this role contains a role mapping that checks for the expiration time. Okay, so I'm going to add another rule, and that's a tips role equals MAC caching. Okay, so if the time is before the expiration time that has been set after the web logon, then this rule is applied. So for this rule, I will apply the guest profile. And then the last rule that I'm going to add is for the redirection. It's very straightforward. So it's a rule that always redirects when the client, when other rules did not have a match. So I'm only gonna apply the user authenticated condition here, and then I'm going to apply the redirect profile. So this looks very clean and easy. So the top one is for the network camera, the MAC caching role is for the guest, and then if everything fails, I am redirecting the client. Oh yeah, and the other thing I need to do is I need to set a default profile, which is deny access. Next is the web authentication policy. Let's call it UBT web auth. I'm going to set the default profile to update endpoint known. And for the rules, I will be adding so I need to assign the user authenticated rule here. Okay, tips role equals user authenticated. So when the user is authenticated, I need to perform the port bounce, and in addition I need to set the expiry, I need to trigger the expiry profile that sets the expiry time to 1 day. Okay, that's the web auth. And then the third one, the third policy is for the 802.1x. Set the default profile to deny access. And in the rules are very straightforward. It's going to be the user authenticated condition, and for the user authenticated condition I am pushing the .1x profile. And then the services. I need to create 3 services for MAC authentication, web authentication, and 802.1x. Let me start with the MAC authentication service. Let's give it a name. And for the MAC authentication service, I have to enable authorization because I am also performing some checks against the time database and the endpoint database. Okay, so I will allow all MAC authentication, and for the authentication source I will add the local user repository. For authorization, as I said, I need to add the time source and the endpoints repository. And in the role section, I need to assign the captive portal expiry role mapping here. So that's checking on the expiry time. And then in the enforcement tab, I am pushing the MAC auth policy, and I need to set the cached results. So I need to tick that box. So that's needed because that's needed for the captive portal because the captive portal performs multiple authentications, and then it makes ClearPass caching those sessions. Okay, that's it for the MAC authentication service. Let's add another one for the web authentication service. It's a web-based authentication. Also going to enable authorization here. Let's call it UBT LUR web auth. My authentication source is the local user repository. For the authorization, I need to add the endpoints database and time source as well. And then for the enforcement, I am using the web auth policy here. Okay. And then the final service, which is the 802.1x service. That's an 802.1x wired service. Slur.1x. I'm not doing any authorization here. That's a pretty straightforward service. Again, I will be using the local user repository, and my enforcement will be the .1x policy. As said earlier in the video, for the wired switches, I need to create a different captive portal page because the authentication process differs from the mobility controllers. So what I will do is I will create a new web login page, or let's call it UBT captive portal. And so the page name is wired portal. Remember that I configured this URL on the switch. It's a Hewlett-Packard Enterprise vendor. I'm not going to do any checks. The other thing what I want to do here is I want to force the client to be redirected to a different site using the Galleria skin. And the other thing that I'm going to set here, so the login delay now is set to 60 seconds, which is a pretty long time. So I'm going to set this to 10 seconds because I've set the port bounce timer to 2 seconds. So you don't need that long time to reconnect to the network. And that's it for the captive portal page. Okay, reload that, and that's it for the captive portal. Now before I put it to the test, let me do some additional cleanup. The first thing I'm going to do is check out the devices. So remember that I've configured a device here that is actually a full subnet of devices. So the advantage of this is that you don't need many entries in the section. The disadvantage is that these devices all have to be the same family. So let me show you the entry. So you can see here the vendor name is Aruba. Now my access switch, my wired switch, although it is an Aruba switch, the dictionary, so the switch is using a different dictionary. So it's using the Hewlett-Packard Enterprise dictionary. So that means that I cannot use this subnet for the switches. So what I can do is what I will do is I will change this to the mobility controllers. So what I can also do is you can see here that I can also specify a range. So what I will do is I will specify the mobility controllers here, 155 to 159. Okay, and they are Aruba. And what I'll do here is I will create another entry. Well, I'll call it switches, and I can also assign a different range here, so 250 to 253, for example. Add my radio secret, and I'm going to set the vendor type to Hewlett-Packard Enterprise. Okay, so now I can use this entry for my switches. Another thing that I want to do is disable the port-based tunneling services because I don't want them to interfere with my user-based tunneling services. And then the other thing I need to do is the categorization of the camera in the endpoints database. So remember the policy configuration. Let me show you that policy configuration. You can see here the endpoints repository category equals network camera. So I'm checking on the category in the endpoints database for this, for this camera. So what I have to do is go to the endpoints database and check for that camera entry. So this is the camera entry. It is profiled, so as soon as that camera is profiled, what I can do is I can assign the appropriate device category to that device, to that endpoint. Okay, so now it's known, and it's the device category is network camera. And in the policy, I am checking on that network camera category. Now let me connect all the clients, the 802.1x client, the camera, and the captive portal client. I'm going to log in with the 802.1x client. Okay, providing password. That seems to work. Let me also log in with the guest portal. You don't see it on the screen, but I'm just logging in. Let's see what happens on the access tracker. Okay, let's move to the access tracker. I can see that my 802.1x is successful. My radius output is, I'm pushing the right user role, so that's good. And the camera, let me see if the camera is working. Yeah, so you can see the user authenticated here, and I'm pushing the camera role. Now when I look at the captive portal client, I'm getting a login again, so the captive portal client fails. So for the captive portal, you can see here there are 3 authentication requests. So this is the first one, and that first one is sending the redirect role, and then the second one is the web authentication, which is successful, and the web authentication pushes the port bounce and the captive portal expiry profile, so it updates the expiry value. And now the third one is okay. Oh, it's sending the redirect again, so it's not applying the guest. Okay, so that's strange. So let me just troubleshoot it a bit. Let's check the MAC auth first. So what I'm doing in the MAC auth policy is I want to have this profile pushed. So I'm using this MAC caching role here. So it seems that there's something wrong in the MAC caching role, and that is probably related to the role mapping. Let me check the captive portal role mapping. Let's see what is wrong. I see that there's an error in this value. This dash should not be there, and the time source should be now dt. It shouldn't be now, but now dt. So when I check the sources, time source, it should be now dt. So I'm comparing now dt with 1 day dt. So it's not. I'm not using now, right? So I need to change that. Let me see if I change that rule. Let me just copy that one first and edit the rule. Change it to now dt less than, and then provide the value. Then I need to remove that dash, make it a space, save it, And just let me try and log on again on the captive portal. Okay, so my web authentication is successful. Let me check the access tracker. Accept, and my output is the bounce and the captive portal expiry. Yeah, and I now see that on my client laptop is that the third authentication is successful. So let me check the output. Yes, so I'm pushing the guest user role now. So that's all working now. And the other thing I can check is the show port access client. So you can see that for the clients, let me just make it a little bit bigger. Issue the command again. So I have my camera sitting on port 4, my captive portal guest sitting on port 5, and my employee, my 802.1x, sitting on port 6. And that's all for now, folks. In the next video I will show you how to establish a tunnel to the mobility controllers using secondary user roles with local user roles that are configured on the switches. Thank you so much for watching. And let us know if you have any suggestions, ideas or questions, and if you haven't done yet, get your free subscription to the ABC Networking channel. See you later and have a great day.